Hi everyone, and welcome to another episode of Mr. Carlson's Lab. In the previous video, I had many requests to go through a complete alignment on this radio receiver, and that's what we're going to do in this video. And as a bonus, all the way through this video, I'll be giving hints and tips in order to make your alignment procedure all that much easier. So there's a lot of shortcuts that can be taken when you're doing an alignment that make the alignment just as effective as if you follow it right from the beginning to the end. And I'll talk a lot about that. I'll also do some explaining about the schematic. So basically, this video is completely about tuning receivers, at least the AM receivers at any rate. So what we're going to do is we're going to tune up the radio receiver using the old method. So basically it's a peaking method. We're just going to be peaking everything up. And then what we're going to do is we're going to take a look at that method on a spectrum analyzer to see how well that method actually works. So there's a lot of people that believe in sweeping IF sections, and there's a lot of people that just believe in peaking IF sections. So let's see the difference in this video. Let's get started. The first thing that we want to do before we start the alignment on this radio receiver is we want to take note of these little marks here. So those little marks are designed so that we have alignment points. Now sometimes some of these alignment points are at the factory just for checking the dial tracking, and they only give you a generic setup procedure, I guess you could say, in the actual schematic itself. So some of these alignment points could very well be in-house, and some are just designed to set it up for the initial alignment. So we'll find that out as we go along. So you can see there's a dial point here, a dial point here, a dial point here, and a dial point here. So now you're looking at that, probably saying, well, what does that mean? There's nothing here. Well, what we want to do is we want to take the case of the radio, and we want to slip this in the case, and we want to see where those line up on the dial. So it might be a little bit difficult to see, but you can see right here, that little alignment point is right in line with the end of the dial. This one is right at 600 AM. If we look at this one right here, you can see this alignment point is at 1000 AM. So we can get a little bit better light on that, right at 1000 AM. And the other one we have covered up by the needle is at 1200, and then we would have 1300 and 1400. So this one is at 1300 AM. So 1300, 1000, 600, and this is the beginning of the dial. So that's before 55, all right? So 550 kilohertz, it's before that. So this is going to be the dial end, okay? So what I'll do is I'll turn this. The first thing that we want to do before we start the alignment is we want to make sure that the needle is going from end to end correctly. We don't want overlap on this end and then it not to go right down to the bottom on this end. Okay, so what I'll do is I'll rotate this all the way down to the bottom. And that's the bottom. Now you can see it's going beyond this bottom line. It's going beyond that alignment point. So it's going too far this way. So what I'll do is I'll move this up to the top. Try and get this glare off of here. Maybe there. So I'll move this up to the top now. And as you can see, it doesn't make it to this end. All right, so it's going too far this way, and it's not going to this end. So what does that tell us? Well, that tells us that the needle pointer needs alignment on the dial string first. Before we do any portion of the alignment, we want to get that finished. So I'll just tip this backwards again, get this out of the case, move this off to the side here again. So if I rotate this down to the bottom, a little bit easier to do like this. So if I rotate that down to the bottom, as you can see, it's way out. So I want to hold the dial string and see if I can get this over to the other side. Well, it was very loose on there. So it's down at the bottom. I'm going to slide this up just a little bit. And we'll see if we can get that in there like so. And it could probably use just a little bit of a snug down to there. And there it is. So that's the bottom end of the dial aligned. So now if I was to slide this in the case, I'll just rotate this up to the top because it's easier to do this when this is out of the case and there is no knob on the little dial shaft there. So I'll put this back in and we should be very close to that last line. Look at that. Does it get any closer? I actually have to move this off the line so that you can see it. There it is. So that's done. So now the dial is aligned, so we've got that out of the way. Very first thing that should be checked all the time. Okay, so I'll get this out of here again. Now I don't need the case because the rest of the alignment can pretty much be done without the case, and we can use these factory markers to check dial tracking. All right, even though this is not going to be mentioned in the alignment procedure as you're about to see. So I'll go get the schematic, we'll take a look at that, and we'll take a look at their alignment procedure, and I'll explain the alignment procedure, and it'll give you some hints and tips to maybe bypass some of the stuff that you might not need to do. I'll talk more about that in just a moment. This is the alignment procedure for the RCA Little Master radio receiver. What I'm going to do is I'm going to attempt to demystify what they talk about in the alignment procedure. So way back when they wrote these, they just expected the radio repairman to know the stuff that they have omitted, or in some cases their cryptic language, the way that they write this stuff. So what I'm going to do is I'm going to take this and I guess you could say convert it to a way that this would be said nowadays. And I'll fill in all the blanks that they've left out here. So this is very valid for alignment procedures in many, many radio receivers. They do this. So the information and the knowledge that I'm going to share with you now can be put forward towards many other radio alignments. Another thing that I'm going to tell you about is the step that you can skip in this alignment. In many cases, you don't need to start right at step 1. You can start at step 2 and so forth and do the alignment and get a perfect result without having to start at step 1. I'll talk a lot about that as well. So that saves a lot of time and it's just not needed to basically start from the beginning and go to the end. I'll talk more about skipping step 1 here in just a moment. So we'll start with some of their cryptic language. Output meter alignment. What does that mean? Well, that means that you're going to be using a FET voltmeter or a vacuum tube voltmeter, and you're going to be connecting that across the speaker's voice coil to do this alignment. Whenever you see visual alignment method, so they'll say visual alignment method or something like that, jumble the words up a little bit, that means that you're using an oscilloscope in order to do this, or in some cases, you're even sweeping it. So some of the radio receivers from way back when, especially the communications receivers, rely on the radio serviceman or the radio repairman to use a sweep method to align it in order to get selectivity curves in the actual IF section of the radio receiver. So we'll talk more about that when we come across a radio that requires an actual swept method. Okay, so this is a very easy type of alignment. This is basically just known as peaking everything. So all we're doing is we're peaking this thing for maximum sensitivity by twisting the adjustments in the tops of the IF transformer and on that variable capacitor that you see. So if you watch the previous video to this, you see me just kind of doing a preliminary tune on it just to try and get the thing to work. Now we're going to actually do a correct alignment on this radio receiver. It says test oscillator. When you see test oscillator, more cryptic language, that means signal generator nowadays, okay? A signal generator is not a function generator. That is different again, All right, so test oscillator in this case means you're using a signal generator. Connect the low side of the test oscillator. Connect the low side of the signal generator to the receiver chassis. When they say low side, they mean the common lead of your signal generator. Connect that to the chassis through a 0.01 microfarad capacitor. So what they want you to do is isolate the low side of your signal generator from the chassis of the radio receiver. And that is one extra step of precaution because this is an All-American 5 transformerless set. Okay, so what I'll do here is I'll explain a little bit more about that quite shortly. It says, and keep the output as low as possible to avoid AVC action. Okay, so they want you to keep the output of your signal generator as low as possible so that you don't basically start putting negative voltages on the grids of both of these tubes here. What is the AVC? You can look at the AVC as a governor inside the radio receiver. Basically, it's controlling the throttle of the radio receiver. So what happens is when you have a very strong radio signal coming in, we have diodes here, and it's going to create a negative voltage on this line. This capacitor creates a time constant, and it also acts as some filtering. And that strong signal will create a high negative voltage. That high negative voltage will be applied to the control grid, or where the signal goes into these tubes. It'll be applied to the control grids of these tubes, and what it's going to do is bring the gain of these tubes down because you're biasing these tubes off. Okay, so you can see this is where the AVC voltage is going to appear. It goes through the IF transformer. This is DC now, okay? So the DC goes through the IF transformer. So we have signal on here, and we also have direct current going through here at the same time. So the direct current is going to go right up to that grid. And the higher the negative voltage, the more that it's shutting this tube off. All right, so it's basically bringing the throttle down. And it's the same thing with this. The AVC line goes over to the front end. It goes through the loop antenna. So the DC from here is going through the loop. And it goes right into the control grid of the 12SA7. So it's bringing the gain of both of these tubes down when a strong signal's here. When the strong signal is removed and you have a weak signal, that negative bias is now going to go more towards positive. So basically it's going to go from, say, we'll just use this as an example, okay? So it's going to go from negative 10 volts, negative 9, 8, 7, 6, 5, 4, 3, 2, and it'll get close to being 0, so there won't be so much negative voltage. As that negative voltage goes more positive, these tubes start to turn on and they start to open their ears. They start to listen more. So basically what it's doing is it's turning the throttle up again so that you can hear weak signals, okay? So that's what it's doing. Now, this capacitor here, you can amend this value. This is 0.05 microfarad. If you want slower AVC action and you want it to hang in longer, you can change that to, say, a 0.1 microfarad. If you wanted quicker AVC action, you can take that down to, say, 0.022. All right, so this acts as a time constant on this line here. I'll talk more about amending these radios and basically supercharging All-American 5 radio receivers in the future. There's so many things you can do to these things to really bring them to life. So at any rate, I'll talk more about that in the future, including adding more tubes to them and things like that as well. So basically, that's what we want to do. So we don't want AVC action. We want to keep the signal at the input for the alignment here as low as possible so we don't create that negative DC voltage. We want this thing to be listening as hard as we can. Another thing I should mention about this output meter alignment portion here is it says here, you're going to be putting your vacuum tube voltmeter across the voice coil and you're going to turn the receiver volume control to maximum. The reason that you're doing that is because, of course, they're thinking that the receiver is completely deaf and, you're going to be cramming the signal in here, which we'll be talking about at a moment. Another reason that they want you to turn that volume control to maximum is you're not listening to your alignment tone at maximum. They just want the sensitivity as high as possible. If you're going to be putting your vacuum tube voltmeter across the voice coil of the speaker itself looks like a dead short. And not only do you have to drive the voice coil with your output transformer here, you also have to get meter deflection on your FET voltmeter or your VTVM. So eliminating the actual voice coil on the speaker and just having the secondary of the transformer open is fine as long as you keep the audio level low. All right, you want to keep the audio level low over here. A lot of people think that no matter what happens, there always needs to be a load across the secondary of the transformer. Not true. Why is that? Well, if there's no audio signal on the control grid of the audio output tube, this looks like pure DC resistance. It doesn't even look like a transformer to this tube. If there's no audio signal here, this is pure DC resistance. The moment that you start putting an audio signal here, now this starts looking like an inductor or a transformer to this 50L6 tube. So there's a difference between impedance and resistance. Impedance is an AC measurement. Resistance is a DC measurement. So that's what we're transforming from one to the other all by just applying an audio signal here. So again, no audio signal on the grid. The tube is completely quiet. This does not look like a transformer. This looks like pure DC resistance here. So by giving this just a little bit of audio, enough audio to deflect a vacuum tube voltmeter on its most sensitive scale would be absolutely fine. Now, I'm saying this, you don't want to be cranking the audio up to a super loud level. You want just enough to tickle the VTVM so that you can get a measurement. Okay. If you're unsure about this and you think that you might get an audio excursion so that it's very, very loud, you can disconnect the speaker's voice coil, but replace it with a load. Okay, so what you'd want to do, if it's a 4 ohm speaker, just put a 4 ohm resistor across this, and then you can attach your VTVM across that. Again, if you do that, your audio level is going to have to be higher in order to drive your vacuum tube voltmeter because, again, you're basically taking the secondary winding of this transformer and you're shorting it with a 4 ohm load, okay? So a way to get around that and to use a VTVM on its most sensitive scale and get, decent meter deflection is by just eliminating the load. Again, you have to keep the audio drive level low. Now, vacuum tubes themselves are high impedance devices. They're not like transistors, okay? And they're also, vacuum tubes are very much, at least the input section, is very much like a FET. They're a voltage-driven device, whereas transistors are current-driven devices. You need current to turn on transistors. Whereas this, it's extremely high impedance on the grid, right? So just the littlest bit of audio signal on here will present a little bit of voltage on the output here, enough to drive a VTVM. Just keep the audio levels low. I'll talk more about audio transformers and the output stages in amplifiers and things like that in this DC and AC resistance things here in future videos. Again, this is this is about an alignment. This isn't really getting so much into the technical end of things here. So I'll address this in future videos. There's so much information here. I could probably spend hours just explaining this and this together. So I want to narrate this as easy as I can so that we can get into this alignment. And if you would like to hear different portions of this alignment, I'm always reading the comments. So if you have comments or suggestions on things that you would like to hear about in these radio receivers, and there's enough of that, particular request, I will dedicate a video to that. All right. Again, there's so much to cover in here, right? These radio receivers are just, they do so many things and they're full of so many different aspects. So at any rate here, what we want to do, it says presetting the dial. Okay. So that's what we did in the beginning. It says with the gain condenser in full mesh. Okay, so I'll grab the radio receiver here and turn it back upside down. When they say with the gained condenser, so there's two sections here gained together, with that in full mesh. So full mesh means that these plates are inside the other plates. That's full mesh. Full mesh, lowest end of the dial. Okay, they want us to align this with the first mark right here, and that's what we've done. Okay. So it says here, with the gain condenser in full mesh, the pointer should be adjusted so that it lines up with the first marker on the left of the dial plate. That's what we've already done. That's the very first thing that needs to be done before any portion of the alignment is completed. With the antenna, it says here, the antenna connection here, it says the set is equipped with a built-in loop antenna. So that loop antenna is this coily wire on the back side that you see here. Okay. If an outdoor antenna is used, it may be connected to the antenna terminal on the rear of the cabinet. We're going to also be using that for some of the alignment. Antenna terminal, rear of the cabinet. Okay. Okay, on the rear of the cabinet, it should not be longer than 100 feet, including lead-in. Okay, so there's a bunch of reasons why they don't want this to be longer than 100 feet. One of the reasons is that your radio receiver is a transmitter as well. So as you're receiving radio signals, it's transmitting a signal back out the antenna. Okay, way back in the day, even modern radio receivers are the same thing. Okay, so way back in the day, they didn't want you to be, I guess you could say, tracked or whatever by having a super long antenna. And not only that, they also wanted it not to be longer than 100 feet because they didn't want you to overload the radio receiver. Way back when, radio stations that were on AM were known as flamethrowers, and they had a lot of output power. So there's some pretty big RF output tubes in those radio stations way back in the day. And more power, more better way back when, right? So they wanted you to keep the antenna, possibly as short as, as you could make it. So it says, if it's basically longer, so if it's longer, connect a 100 to 200, here's more cryptic language, microfarad. Microfarad is picofarad. So they want you to basically keep it as short as possible, and then if it is longer than 100 feet, put a capacitor in series with that antenna at the output jack. And basically what that's going to do is that's going to attenuate some of the signals coming in, and it's also going to attenuate the signal that you're transmitting back out that antenna. Okay, so that's basically just demystifying what they're saying there. The rest we don't really have to worry about because we're not going to be operating this thing on DC. And things like that. Since this is a transformerless set, this can work on DC as well. So if you strung a whole bunch of batteries together, you could operate this on DC. If it had a transformer, obviously you can't operate this on DC, because if you had a transformer and you attach the primary to DC, you would get some smoke in a short period of time. So if you were to use this on DC, you plugged it in and it didn't work, you would basically take the plug out, turn the plug around, and then it would work, because tubes conduct in basically in one direction, and we have a diode in the front here and everything like that. So these are transformerless sets. So the reason they eliminated the transformer in these sets is to save costs way back when. So basically more people could afford radio receivers, put it that way. Radio receivers way back when were worth a lot of money. That's just the way they were. They were worth, in a nowadays comparison, if you were to buy a radio receiver like this and it had a nice big power transformer in it, you could compare that to buying a brand new cell phone or maybe a laptop nowadays. All right, these things were worth a lot of money in 1940s dollars, right? So in order to cut costs so that everybody could afford these things, is they wanted to reduce the chunk of iron in the front end. So they get rid of the transformer and they just made a transformerless set. Now, because they've reduced that chunk of iron, there is no isolation when you're working on one of these things between this and the AC line. So radio technicians way back when would have a thing on their bench called an isolation transformer. It's basically just a one-to-one transformer. The isolation transformer would plug into the mains or the source, and then this would plug into the isolation transformer, and it would isolate the radio from the mains, which would make this radio safer to work on. It doesn't make it safe, but it makes it safer to work on. When I say safer, you got to realize that you still have, 117 or whatever coming out of your isolation transformer. The whole radio is operating on that. So it's operating at elevated anode or plate voltages. So vacuum tubes run at elevated plate or anode voltages in order to create the electron flow in here so that they work correctly. They're not like transistors or FETs that can run on low voltage. These things run at high anode voltages. There are vacuum tubes that do run at low anode voltages, and they're known as space charge tubes. And I'll talk about that in future videos. We're not dealing with that right now, so we'll just keep to this thing. So keep in mind, if you're working on one of these radio sets, an isolation transformer is a definite must, and know that there is higher voltages in here. So if you're working on this, you're doing so at your own risk. If you're uncomfortable with working on vacuum tube equipment with elevated voltages and current, do not work on one of these radio receivers. Again, if you're following along, you're doing so at your own risk. All right, so what I'm going to do now is get the radio into the shot here, and we'll start talking about the alignment, and I'll go from the alignment to the radio receiver and show you how to decode this chunk of information that they have so nicely left so much information out of. The first thing it tells us to do here in step 1 is, it says here 12SK7 grid in series with a 0.01 microfarad capacitor. So if we look at the schematic here, this is the grid of the 12SK7. So what they're wanting us to do is feed the signal in the grid so that we can align this one here. So this is before this tube. So if we attach the signal into the grid here, we don't align this, we're just aligning this one side. Now, since this radio receiver receives somewhat well already, we can skip this step because there's signal getting through the chain. As we know in the previous video, this radio is receiving okay. So we can completely skip this step. There's no reason to do this. The only reason we would want to feed this section here first is if this radio was so incredibly out of tune, again, screwdrivered into orbit, and there is no signal getting through whatsoever. By feeding the signal in here first allows us to adjust this stage first so that we can get some gain happening, and then we would move back over to this stage, and then we could align this one. So we can completely skip that and still get a really good alignment. The alignment will be just the same if we start over here at this point. Okay, so we don't need to do that. So we're going to skip this step here, and we're going to move to the 12SA7 grid with a 0.01 microfarad capacitor. So I'm going to tie in a capacitor here, and then my signal generator is going to attach to that. Again, I have this attached to an isolation transformer and current limited variac supply. So the signal will go into here, right into this point right here. So this is where it attaches to that antenna post. So this goes right through this. So the actual stator portion of this variable capacitor is attached right through this. So this connection goes right over to the other side, and then through that wire down into the bottom here and attaches to the grid here. So I can just tie into this point. It's just nice and easy. Same place right here, so I don't even need to go under the chassis for this. So what I'm going to do is I'll show you how I have my signal generator set up, and we're going to be using a vacuum tube voltmeter across the coil. I'll give you an example of how the vacuum tube voltmeter works with the speaker hooked up and without the speaker hooked up. So we'll be back in just a moment. Here's the signal generator and how it's set up. So to begin, I have the frequency at 455 kilohertz. Now this is the IF frequency. We'll have to change this for the RF alignment. So I'm just going to be pushing this through the main tuning condenser, right through the IF chain, and that also uses the front end of the radio receiver as a buffer, so we get a really good IF alignment by doing this. The output level of this is about 500 microvolts. Okay, so that's what's coming out of this and going through this coax right now. Another thing that they don't tell you in the instructions or the alignment procedure is that 455 kilohertz signal needs to be modulated with a tone so that we can get deflection on the VTVM. So if we don't have a tone, we're not going to get any type of deflection. So we have to put a 400 cycle tone on this at about 50% modulated. Okay, so anywhere between 30 and 50 would be fine. I just default to 50 all the time. So we're modulating this to 50% with a 400 cycle tone. The output is at 500 microvolts. And again, I'll be changing this throughout the RF alignment portion of this. I'm ready to start the 455 kC alignment. And again, they don't tell you to modulate this. You definitely have to put a 400 cycle or 1000 cycle tone on this, or you won't get any meter deflection. So again, some information that they're just expecting you to know, and they're not including that. I'll give you an example here of what happens if we remove the tone. So there's the 455 kC signal with a tone on it. So you can see we have meter deflection, right? So if I shut that tone off, the signal's still there, but there's no tone, right? So that's just with no tone. The 455 kC signal is still there, but no tone. And again, I'll turn the tone back on. And as you can see, we get meter deflection. Now here's an example. This is an example of the speaker in circuit and out of circuit at low volume. Okay, so this is pretty low volume here. And as you can see, we don't have very much meter deflection. And this is on my most sensitive scale. I don't know if you can see that. Oh, back this out a bit. This is on my most sensitive scale here on this VTVM. Okay, so now if I remove the speaker, so this is just attached to the audio output transformer. Look at how nice that is. So the audio level is low enough that there's going to be no damage, nothing's going to happen, but now I get nice needle deflection and I can really see that needle move. And we don't need to listen to that horrible tone as I'm doing this. So again, that's with this, you know, the speaker in circuit, and that's with the speaker out of circuit. Oh, and I'll give you an example again. I'll shut the tone off, the tone that they're not telling you to add. So here we go. No tone. You see, there's nothing to work with. So why they wouldn't tell you to modulate that is just silly. And I'll turn it back on. So that's just the way that things went way back in the day. They just expect you to know this. So what I'm going to do now is I'm just going to align these points for a peak. We'll use an insulated screwdriver because these are pretty loose. And we're just going to be looking for a peak. So if you recall in the last video, we moved these things around to try and find a peak just for maximum static. So now that we're actually doing alignment, we're doing this properly with a signal generator. Let's see how far out this actually is. Okay. So here we go. Wow. See that? So there's a peak there. Move over to this one. Wow, very out of alignment. Look at that, how far off that is. So I turned the volume down to get this off the end of the scale. Again, that wasn't extremely loud, it just went over the end. So no problems not having the speaker in circuit. Now I'll go over to this one here. I can't see this because this is way over under the camera. Okay, so there we go. Again, just tuning for a peak. If you pass the peak, say you're going back down, or you come up and you pass the peak again, you just want to basically work your way up to the peak and then just a very small movement, rock either side of that, and then till you find your peak. Okay, we'll go over to this one. And I'll turn the volume down again. So you can see by peaking this up by static is not adequate. This needs to be done properly with a 455 kilocycle signal. So now we're really peaking this section up. And when we do the visual alignment later, so if you watched the last portion, I explained the difference between an output meter alignment and a visual alignment. That's in the explanation where I was talking about the alignment procedure. If you didn't catch that, you might want to go back and listen to that again. Or if you skipped over that, I explained the difference between a visual alignment and this alignment here. So now what I'm going to do is I'm going to go through this again. All right, so I'll go through this one more time. And now that this is up so far, what I'm going to do, look at that, how I can still keep peaking this up. So now what I'll do is I'll put the speaker back in. Okay. Okay, so that's not very loud. So what I'm going to do now is I'm going to take down the signal on the signal generator. Okay, so what I'll do is I'll just move this down. I'll give you an example of that here. All right, so I'll take this down to say 200 microvolts. We'll try 100. It's still pretty loud. Okay, that's about low enough. I can start hearing the static in there now. Okay. So what I'll do is I'll turn this off. So now we get meter deflection again at a very low volume. I'll just turn the volume up just a touch. And I'll go through this again. So we definitely don't have very much, if any, AVC action going on right now. I got a little bit more of a peek out of that. Go over here. As you can see, more of a peek out of that. And over here. Now it's getting so incredibly sensitive that even me moving close to this is probably going to affect this a little bit. So I'll go back and do this again. As you can see, it's getting very sensitive. And you just need to go through the chain a bunch of times and keep redoing this. That was me turning the volume down again a moment ago. Okay, and I'll move over here, do this again. And then we'll take a listen in a moment here again. Okay, so I'm going to turn the volume down again. About there. Very tight. Okay, let's take a listen to that, make sure we're not oscillating. So I'll move this around. We may be oscillating a little bit because we got so much gain right now. So I'll take a listen to this. So you can hear we're getting a bit of oscillation in there because we have so much gain. You can hear that. What I'll do is I'll turn the gain down now again. Let's see. Turn the output of the signal generator down, I should say. So I'll turn this down to 50 microvolts. Still in there, still getting through that cap. 20 microvolts. I can still hear the tone. I don't know if you can hear that. So we can try and peak this up. The tone is almost the same level as the static, so this is going to get difficult. As you can see, the static is way up there. Okay. Yeah, see, we're just going to head into oscillation land. Hear that? It's oscillating. So what I'm going to do is go back up to 100, and I'll leave it at that, and we'll leave it at 100 going through. 100 microvolts. Okay, so we'll do that one more time. You can hear how it's oscillating. So I'll just go through this whole thing one more time, and that will be about it. Okay, that's going to be maximum gain. Right about there. And again, of course, I can adjust that with the volume low. That's going to be maximum gain with no oscillation. So we're right at the verge here. So this is going to be a pretty hot performing receiver here. Lots of gain in the IF section here. So now what we're going to do is we're going to take a look at this on a spectrum analyzer, and let's see how well we did, how close we got this to 455, and how this actually looks. We'll actually see if there's any hiding oscillations or anything. So that's taking this very basic alignment to an extreme, and that's what we're going to do right now. I'll get that all hooked up, and now we'll do the visual method. This is what the result looks like on a spectrum analyzer, and it does need some cleaning up. So there's a 20 kilohertz span here. The center of the screen is 455 kilohertz, right where that little bright dot is. What I need to do is I need to make this even on both sides. I need to move the peak amplitude to the center of the screen, so I have a little bit of retuning to do. This is the benefit of using the visual method. It allows you to actually see what's happening in the IF section versus just peaking. So what I'll do is I'll get this retuned, and I'll show you what it's supposed to look like. Here's what the IF alignment should look like. So a little bit more tuning, and this is what I end up with using the visual method. So this is extremely beneficial to use a spectrum analyzer or some form of a sweep generator to do the tuning in an IF section. So now, on to the RF alignment. I'm on to step number 3, and that's the alignment of the oscillator. I need to make the dial track correctly with the radio stations, so we want this to display what we're listening to at the right spot, right? So it says use a 220 picofarad dummy antenna. So this is my dummy antenna attached to the back here, and that attaches to my signal generator. Tune the signal generator, test oscillator, to 1630 kilocycles, already done. Turn the dial to full clockwise, out of mesh, already done, to save some time here. And now we need to tune C3 until we hear a tone, because this is modulated by 400 cycles again. Again, they're not mentioning that in here, so this whole alignment here is modulated. So you want a 400 cycle tone on this at about 50% modulation or something like that. So as you can see, no radio station, so I need to adjust the trimmer on this oscillator capacitor here, the oscillator portion. So what I'll do is I will get my tuning tool in here. There it is. Turn that down. This is a very touchy adjustment. Alright. Alright, it could be a little better. There it is. Okay, so that is now aligned at the upper portion. The next portion of the alignment, it says move this down to 1500 kilocycles or 1.5 megacycles and tune C1. So we don't know if the dial tracking is correct yet, so we'll just do this anyway. So I'll turn the signal generator to 1.5 megahertz, and I'll just rotate this until I hear tone. And then I will peak up this capacitor here. Okay. Now what I'm going to do is peak up the trimmer on this one over here. Okay, and I can use this insulated screwdriver to do that. Okay, so I'll turn this and maybe we can see this on the meter. Move this up about halfway. And there we go. That will be maximum sensitivity there. We need to readjust this again in the end. So now, next step, move the signal generator to 600 and move this to 600. So I'll move this down to 600. And we'll see if this is in alignment at all. So that is 600 spot on right there. So I'll turn this to 600. 600 kilocycles. That's a signal generator. It's very close. So there is another station, and you can see how hard this is trying to receive. There's actual radio stations coming in underneath my signal generator, and the signal generator is connected directly to the antenna jack. So what does that tell you? This thing is going to be a really hot receiver. So I'll just okay, so that moves that right spot on. It was very close to begin with. So now back up to the other end of the dial. We need to recheck the alignment at the top. So we'll go back up to 1.63 megahertz. And we'll do that again. Okay. Perfect. Back down to 600. So So 600 kilocycles, 600 kilohertz. Right on top of the line. See if we can see that here. That right there, oh, past it, right there. Right on top of the line. Can't get any closer than that. So now we need to go back up to 1500 and peak this again, so 1.5 megahertz. So if this is 13, it's going to be beyond that. Okay, so now I'm just going to peak this up. I'll turn this on so we can see that. Turn that up just a little bit. And I will come in here very carefully. And as you can see, we're pretty much at that peak still. And that's it. That concludes the alignment. I'll put this thing back in the case and let's see how well it receives. I can tell you it's going to receive like crazy. It's receiving with my signal generator pumping a signal into it. Just crazy. So this should be fun. Let's take a listen to the receiver and see how well it receives. You can see I'm just barely moving the volume. It's got lots of volume there. Distance station there.
You gotta show us what they can do for us.
They're not even going to be measuring for. Early on because they.
866. Calm the noise.
Who kind of thinks they're going to hide it
Into them. So
On the European level,
legitimate.
we'll have to wait and see. And Trudeau apologized for his So they got some. There's like three.
For the hope we have, we can
Treat somebody.
ask Joshua.
Tucker Carlson about the documents.
Radio. We just try not to kill it.
Got it. You've been very kind, and I'm very.
There's that religious station that I was talking about, right at 55 right there. So you can see it's receiving so many stations at the same time. There's lots of heterodyning down here because conditions are happening right now. So this is later on in the evening, and this thing is just receiving like crazy. So it's really working well. So it's a nice little old RCA Victor, and they did a nice job putting this thing together. Now, I'm not done with this thing yet. I'm still going to take it apart, and I'm going to replace the line cord and move the switch around and things like that. Again, this is an alignment video, not a restoration video on this thing, right? So I still have some work to do, so a part will come, and I'll go through this thing and make this about as safe as I can. So there you have it. There's the alignment video on this radio receiver. Lots of different alignments. I would have spent more time explaining the visual alignment, the spectrum analyzer portion of this, but as you can see, this video is very long as it is, and that would probably add another half an hour or maybe even more to this. So I'm going to dedicate an entire video showing visual alignment with spectrum analyzers or sweep generators as well. So there's a lot of really interesting things coming here in the future. And of course, tons more restorations are on the way. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be taking a look at all sorts of different electronic devices, solid state and vacuum tube alike. So if you haven't subscribed, now would be a good time to do that. If you want to be notified as soon as I post a new video, don't forget to tap that bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.